Thank you very much. So I'm Daniel Wagner Hall. I've been, as said, teaching beginners programming for 5, 6, 7 years now, mostly as a volunteer, and I've recently become the director of technical education at a nonprofit called Code Your Future. Before that, I've been a software engineer, mostly in some larger tech companies, places like Google and Twitter and Apple, working on often large-scale systems. I wrote my first line of Rust in 2015. It's been my kind of go-to language since about 2018, and I really enjoy it. It's a great language. The thing I want to talk to you about today is how we can get more beginners into Rust. Tim this morning mentioned the Rust mission of empowering everyone, of being a really inclusive community, of getting everyone started and going. And I don't think we're quite as close to that as we could be, but I have some ideas how we could get better. The reason this matters to me is I teach beginners, I teach people who have no background in software, and I teach them to help them change their lives. We'll talk about who some of those people are. Who do I work for? I work with Code Your Future. It's a non-profit. It's a community of volunteers. We're mostly volunteers doing teaching. And we're teaching refugees and other underserved people to get jobs in software engineering. And that jobs focus is really important. Like, software is fun. We hope the people we're teaching enjoy it and find it interesting, but we're really trying to help them get jobs and get their lives into a better place. So far, we've helped about 300 people get into jobs in software. At some pretty exciting places. They're doing some really exciting things. And who is it that we teach? We're teaching really high potential, really smart people who have no software background. Typically, someone who starts on our course has written 0 lines of code before they come to us. They're typically in not amazing life situations. They're in poverty. Probably some bad things have happened to them to get where they are. They probably have families they're caring for. They're probably working in unstable, insecure work, like in warehouses at nights or delivering food by day. And what they really need in life is income and stability, right? They want to be able to raise their families in comfortable situations. They don't want to be worrying about what's happening next. And a job in software is an amazing way to get that, right? Software pays pretty well, and you don't have a lot of worries about your day-to-day when you're there. So what do we teach? We teach a series of courses, and the first one we teach we call Intro to Digital. We're introducing people to HTML and CSS and Google Sheets, and really helping people decide, like, do I like telling computers what to do? Because not everyone does, and that's fine. The earlier you can work that out, the better. After that, we teach a course we call Intro to Programming, which is really focused on decomposing problems. Because that's what we do as software engineers, right? We take big problems and turn them into small problems we know how to solve. We focus a lot on testing. What are the edge cases of this problem? What are the different cases I need to consider? And we do this with JavaScript and SQL. Next course we have is really a software engineering course. Intro to Programming is teaching you, like, what's a variable and a function and a for loop. It's teaching you the mechanics of a programming language. And this software engineering course is really focusing on, like, what's a good program? When should I extract a function? When should I encapsulate things and group them together? When is abstraction useful? What code can I write that my team is going to enjoy working with as we work together? How can I become a professional at this? We mostly do this with Python and JavaScript. And this, we think, is enough for most people to go become a software engineer. We've seen a bunch of people go get excellent jobs with these skills. We have identified one corner of our industry that this isn't enough for, and that's jobs that really deal with scale. And a lot of people in the Rust community are thinking about scale, right? Thinking about distributed systems, thinking about how things fail, thinking about troubleshooting a complex system you don't understand all the parts of. That's a whole separate skill set. And we developed this extra program to cover that. This runs slightly different to most of our programs. The ones I've already described, we run part-time. We teach on Saturdays, and people do learning themselves on evenings and weekends when they have time, because maybe you're staying up all night working in a warehouse. Maybe you're looking after your kids or your parents. So we give a lot of flexibility. We think for these things of scale, it's much harder to do that bit by bit over time. And so Slack came to us. They wanted to hire some of our graduates to be platform SREs for Slack. And we looked at our graduates and went, we absolutely have people you should be hiring, and we have not yet taught them enough skills for them to do that job. But we can fix that. And so we devised a new program. It's a full-time study program. for 3 months. We pay people to quit their jobs, and we pay people to work full-time for 3 months. They're studying all of that time. Then they go do an internship, where they learn stuff on the job. There needs to be that internship there. We only run this program when people have jobs to offer, because I'm not comfortable telling people, quit your job and study with me for 3 months, and maybe you'll get a job in the future. It's not a comfortable thing to do, right? So when there are jobs we can offer, we'll put together this program. We custom tailored this program to what Slack needed for SREs. So it's really focusing on scale and distributed systems and troubleshooting and how things go wrong. It's an intense program. They did some really impressive stuff. We're always looking for more hiring partners. So if you're interested in hiring some really exciting, diverse talent, come talk to me. We have amazing people who are looking for jobs. So we have this extra course, and we teach it in Go. And we're at a Rust conference. And I assume you all have a question in your head, which is, where is the Rust in this map, right? I love Rust. It's my go-to language. I really want to be using it instead of Go in this Engineering at Scale course. I really want to be using it as the first language instead of JavaScript. I think it has a lot going for it that makes it easier to learn than JavaScript. So why aren't we? Well, let's talk about that. What makes a good language for learning? I want to talk about 4 things I think makes the language really good for learning. First is it should be easy to try something out. We learn by doing, right? We don't learn by reading a tutorial or watching a video. We learn by experimenting and getting things wrong and keeping going. Not argue JavaScript is the gold standard at easy to try something out, right? There is like no boilerplate. You write an expression, you write a statement, and it runs. You don't need a main function. You don't need to import anything. You don't even need to install any software. You have a JavaScript interpreter on your computer. You have a web browser. You can run JavaScript there and then. JavaScript is amazing at just trying something out. Go is fine. It's OK. Right now, Rust is not great at this. First thing you need to do is you need to make a cargo toml file. So you maybe run cargo init or cargo new, or maybe you craft one by hand. And then you have a question like, what's a cargo toml file? What's toml? What's in this file? Do I need to care about it? And someone tells you, don't worry about it. And that's an anti-pattern in both teaching and learning. We don't want people to skip over things. There's a few reasons for that. One is when we tell people to skip over things, they learn to skip over things, and they don't know which things they should skip. And so they skip the wrong things. We frequently see people have an error message from a compiler telling them exactly what they did wrong, that they don't understand. And so rather than trying to understand it, they skip over it because it's a scary thing they don't understand. We don't want to train people to skip over things. We want them to understand everything they do and everything they see on the way. Another really important reason we don't want people to skip over things is imposter syndrome. A lot of the people we work with are changing their career later in life. They're working with a 22-year-old who has a computer science degree and more experience than them, and they're already thinking, am I good enough to be here? And every time we tell them to skip over something, that's an opportunity for them to go, I'm not smart enough for this. They wouldn't tell the 22-year-old computer science grad to skip over this. They'd explain it to them. Or they'd already know, I'm not meant to be here. We don't like skipping over things. We want to understand everything we do. So it should be easy to try something out. Fortunately, Rust has a plan here. And huge props to Ed Page and other folks who have been working on this. Cargo script is coming. You will soon be able to run cargo and then a Rust file and just run it. It's going to be amazing. There's a plan to stabilize it, I think, early next year. We'll be there soon. So that's one, not quite there, but coming soon. Second thing is a language should guide you when you're wrong. And this has been like a theme of the talks today, right? Tim talked about it, Georg talked about it. Rust is famous for its error messages. I would argue Rust is the gold standard for guiding you when you're wrong. When you write the wrong code, Rust will tell you that you did something wrong, where you did it wrong, why you did it wrong. Maybe even tell you the code that you meant to write instead. Rust is amazing this. It's one of the reasons that Rust is one of the favorite programming languages on the Stack Overflow survey year after year. It's error messages. And thanks also to Esteban Kuber, who's tirelessly working on this stuff, and Georg and others who are building features and really tracking these things down and making them amazing. Thing number 3 I want to talk about is a language should encourage appropriate abstraction. Abstraction is a really useful tool, right? It helps guide you. It helps you not need to worry about some things, and it helps tell you what you should be doing. I've watched a bunch of people learn Go, and they always run into this same issue. There's this convention in Go: if a function is fallible, it will return two things, a value and an error. And in 99% of cases, it will return one of those two things, either a value or an error. But that's not expressed in the API, right? There are 4 cases here. It could return both. It could return neither. But Go programmers train themselves, if there's an error, the value is useless, because that's almost always the case. Well, it's not always the case. Every now and then, an API returns both. A common example here is the buffered reader API in the standard library. Every single person I've seen learn Go, when they're using the buffered reader, when they're reading like a stream of bytes as chunks, misses the last chunk. Because when you get to the last chunk, Go returns the last chunk as a value, and EOF as an error. Every single person sees there's a non-nil error and assumes the value is useless. The API didn't guide them to do the correct thing, right? It looked the same as all these other APIs that you handle a different way. And again, Rust is amazing at this. Rust is built for expressing abstractions clearly. We have the result type. You handle this by saying either there was a value or there was an error. In this buffered reader case, we would maybe use this custom read result type that has 3 possibilities. An intermediate value, here's a value you should process, but keep looking. A final value, here's a value you should process, there are no more. And an error. This guides you to the 3 possibilities you need to think about. If you don't handle one of them, the compiler will tell you, you're not handling final values. Your code is wrong. You have a bug. This is really useful. This plays in with that telling you when you're wrong. It allows you to craft APIs that also help tell people when they're wrong and how to fix it, how to do something about it, how to coach people into being better engineers. So far, Rust is looking pretty good, right? Easy to try something out, it will be soon. Guides you when you're wrong, amazing. Encourages proper abstraction, really solid. Let's talk about one more property. You should be able to learn one new concept at a time. Let's have a look at some code examples. Here's some JavaScript. It does an HTTP fetch, and it prints out the response. Let's count the concepts we see here that you need to know to understand this code. There's an error handling. There's a try-catch. We need to know what that is, what it does. There's a const here. We need to know what that is. There's a variable assignment. We need to know what's going on there. We're awaiting something. We need to know what that is. We have a function call to this thing called fetch. We need to know what a function call is. Next line is pretty much the same, but one difference, it's using a method call. There's a dot in there. That's something we need to know exists, we need to know about. And then in the error handling, we have some string interpolation. I make this about 7 concepts. We can quibble, right? Maybe you see 5 in there. Maybe const is part of a variable declaration. Maybe you see 10 in there. Maybe you want to split pairs, but like, we're around 7-ish. And 7 is a really important number, it turns out, in learning. Cognitive load theory for decades has been trying to work out how people learn and how people think. And in the 50s, it was basically established as experimentation. People can keep about 7 things in their head at a time when they're thinking or when they're learning. And so abstraction is really useful here, right? That fetch is hiding a lot of complexity. There's a lot of things going on behind that fetch that we don't need to think about. Again, that abstraction means rather than needing to think about 100 concepts in HTTP, we're thinking about 1. We can delve into those details when we need. About 7 concepts here. Let's have a look at a Rust example. Now, I want to point out, this is pretty simple Rust as it goes. There's none of the things people are scared of here, right? There's no lifetimes, there's no borrowing, there's no unsafe. It's pretty like garden variety Rust. Let's count some concepts. Well, first we have dependencies. Rust is a less batteries included language than JavaScript or Go. And so we need to pull in an HTTP client from somewhere. Then we need to pick one. Which HTTP client do we use? And then for this Tokyo dependency, we need to activate some features. We need to know what those are. We have 2 different ways of specifying dependencies. There's a semver string, and there's like a hash in there. In fact, this is TOML. I'm going to pretend the entirety of TOML is one concept. There's a lot of complexity in there. Next, to use async code in Rust, you need a runtime. Rust doesn't ship with the default runtime. Seem to have lost some slides. We're back. Need a runtime. So we need to know what a runtime is. Because in order to choose one, I need to know what one is, right? I need to know why the compiler is telling me my code can't run. Then we need to pick one, because there isn't just one. Then we need to set one up, and there's some syntax here to do that with like an attribute macro. That's a whole piece of syntax I need to understand. There's this async concept, a function, a main function. Where does our code start? In JavaScript, we didn't need to think about where our code starts, right? It just runs the first line. And you think, where do we start? Making some variables, some module scoping, some function calls, some awaits, some matches, OK and error, and that means results, and that means enums. You could argue we could simplify this, right? You could argue we could use unwrap here. But that's a bad thing to do, right? We wouldn't do that in real life. We wouldn't do that in production code. And I don't want to teach people, well, what you do is unwrap, and then the next day teach them never unwrap. It's a bad learning experience, right? You want to teach people things that are representative of what they're working towards. It's also why I'm using async and await in here. You could argue you could use blocking HTTP requests in here. I wouldn't use that in a real server. I wouldn't use that in a real thing that I was doing and taking seriously. So I don't think we should teach people that. Just to next week say to them, yeah, but don't actually do that. It's harder than you think. Have some destructuring, have some of these functions end in an exclamation mark for some reason. I kind of want to know why that is if I'm learning this. I'm curious. Some error handling, some string formatting. There's some squigglies there. Sometimes they have punctuation in the middle, sometimes they don't. 21 concepts. And again, you can quibble, right? You can say there's 15. You can say there's 30. But we're pretty far from that 7. Now I'm going to argue it doesn't have to be this complicated. Let's take that runtime example. Imagine if Rust shipped with a default runtime. You could replace it if you wanted. You can use Tokyos if you want, but it could ship with one. Let's count the concepts we wouldn't need there. If you wanted to learn, say, about async await just on its own. We wouldn't need to enable features on Tokyo. We wouldn't need to know what a runtime is. We wouldn't need to pick one. We wouldn't need to set up this attribute macro wrapper around main. Maybe even wouldn't even need to pick a dependency at all, or no dependencies exist if we're just learning about async await. Already that's 5 or 6 concepts we can get rid of just to learn what async and await are. That would be an easier learning experience, right? I don't think it would be a problem for the language. You can still swap in a complex runtime if you need, when you run into a problem that needs it. We have this with panic handlers, right? We have a default panic handler. You can override it if you want special behavior. But there's a default. That means you don't need to think about that to get started. So Go Go has done this really well. And it slightly pains me to be praising Go in comparison to Rust right now. But this is something they've done really well. They simplified their on-ramp. On the left, we have a fairly standard hello world program, right? We import fmt. We use fmt.printf to format some strings out. On the right is equivalent code. There's no import, and there's no %s or %d going on. These two things do exactly the same thing. Now, I can't speak to the intentions of the Go authors when they added this global print function to Go. But I suspect they realized the first program someone writes, they're probably going to want to print something. Maybe we can avoid them needing to learn about our module system to write their first program. I suspect they also thought, whenever you're learning something, say you're learning about threading or error handling, you're probably going to want to print stuff too. So they've avoided needing to learn about imports and needing to learn about %s and %d formatting for every concept that you learn when you're learning Go. I don't think the code on the right is bad code, right? If someone, this isn't like the unwrap case, where there's some problem with this code. It's just a bit simpler. If you need the complexity of string formatting, you can reach for it. If you don't, you can do the simpler thing. We could do that in Rust, right? Think of that runtime as an example. We could have a default runtime, and you can upgrade when you need. So back to our original mission, getting more beginners into Rust, helping people change their lives, right? Empowering everyone to get themselves into a better place. What can we do about it? First thing is think about the materials that we learn from. At Code Future, we strongly prefer pointing at existing materials rather than writing new ones wherever we can. We're happy to write materials if we need, and they're all free and open source, but we'd rather reference something that's great. I've surveyed all of the Rust tutorials I can find, and by far my favorite of them is Main Matter's 100 Exercises to Learn Rust. And again, huge thanks to Luca Palmieri and other folks who have been working on that. It does all of these things. It tries to introduce concepts one at a time. It's learning by doing. You write a small program. You see how it works. You write a slightly more complicated program. I've watched a bunch of novice programmers try and learn Rust from it, and I've seen some things they get tripped up on. I found some issues in the open source repo. So if you have an hour, go and fix one of them. Make something a little simpler for people to learn. It's a great resource, but the very first lesson teaches way too many things because of that fundamental complexity in Rust that we've introduced. It doesn't need to be there, but we have. So next, think back to Georg's talk about how we can improve the language, about RFCs. Think about what we could do to reduce the number of concepts you need to learn to get going. In a lot of RFCs that I see, we talk about how wonderful it is there's only one way to do things, how orthogonal features are, and how if you already know these 6 or 7 concepts, this next one will slot in really nicely. I don't often see people asking the question, how few concepts do I need to start using this feature? Start thinking about it. Next up, I wouldn't have noticed a lot of these things 5 years ago. I'm an experienced software engineer, and I suspect a lot of people in this room were experienced software engineers when they started learning Rust. And so I didn't notice how much assumed knowledge there was when I got started. By volunteering and teaching people going from scratch, I see what they get stuck on. I see what confuses them. I see what doesn't work for them. And it's helped me become a better engineer. I think about API design differently now that I've seen people get confused by bad APIs. Come talk to me about volunteering, helping some people learn, helping bring up the next generation. The last one is, I can't be teaching people Rust if they don't have jobs to go do in Rust. Right? We're a jobs program. We're trying to get people to improve their lives. They need jobs to do that. And so I help get some of my graduates hired. If you're a hiring manager, come talk to me after the talk. We'll have a discussion. If you're not, think about how you onboard junior people onto your team. Maybe you have an internship program, and maybe it only ever takes interns from the same small set of universities. Maybe you could diversify that and bring people in from other streams. I've worked with companies who have needed to go through that process, who have had really exclusive internship programs, who have opened that up. Doesn't mean compromising on quality. They're still amazing people. They're just coming from a different path. If you don't have an internship program, if you're a team that has never hired a junior engineer before, because those exist, right? The Slack SRE team we worked with have never hired a junior engineer before. That's not a role that junior engineers tend to go into. There's no training program to become an SRE. Well, there wasn't until we made one. We can still talk. One thing we have a lot of experience of is helping people be better mentors, helping people give better onboarding journeys to junior engineers. I'd love to try and get more people into Rust. I'd love to try and get more junior engineers into the industry, and I'd love them to be doing it in Rust because it's the right way for them to doing it. Right way for them to be doing it. I'm going to be around all day. I'd love to talk about any of these things, about teaching, about making Rust better, about volunteering, about hiring. Come talk to me. Thank you very much.